Hi. Now, in some sequences, it is not possible to write an expression for u n. But what we can do, we can use the previous term to determine the following term. Now, that is called a recurrence relation. And here, we have such a case. Now, for recurrence relations, you are given the first term of your sequence because you need a starting point. A sequence is given by the following. u1 is equal to 4, un plus 1 is equal to un plus 3. So what does this mean? Well, this tells us to get the second term, we add 3 to the first term. To get the third term, we add 3 to the second term. That may seem a bit confusing, but let's just go through the example. Write down the first 4 terms of the sequence. Alright, so we know that un plus 1 is equal to un plus 3. We know u1 is equal to 4. We know our first term. So u2, which I write at, u2. u2 is u of 1 plus 1, right? That's still 2. So u2, so this case n is 1. See if I can put that in a different color so you see. So n is 1. So I know that u2 is simply u1 plus 3, which would be 4 plus 3, which is 7. So my second term is 7. Now we go on to u3. u3 is u of 2 plus 1, which would simply be u2 plus 3, which is 7 plus 3, which is 10. And finally, u4, which is u3. So sorry about that, u3 plus 1, which is u3 plus 3. u3 we just worked out to be 10. So this is simply 10 plus 3, which is 13. So let's write our sequence. We would have 4, 7, 10, 13. And if we go on indefinitely, ... Well, you may be saying that this sequence could have been written as un. Yes, that's true. But as we said, we want to be able to use a recurrence relationship where each consecutive term is dependent on the first term. So this is how we would develop our sequence using the recurrence relationship. So this is a good introductory example to get you accustomed to the concept of the recurrence relationship. So thank you for watching this tutorial, and I hope that you found it helpful.